Good morning students, welcome to our online video class of chemistry. Today we are going to start new chapter 4, chemical kinetics. Like thermodynamics, chemical equilibrium, chemical kinetics is also important. We all know that chemical reactions occurs in widely varying rates. And chemical kinetics is a branch of science which deals with the study of rate of reactions. And now let us understand more about chemical kinetics. We all know that chemical processes are accompanied by chemical reactions. In simply we say the process which involve chemical change, that is chemical reaction. Since energy change are involved in those reactions. To proceed a reaction, certain conditions have to be fulfilled as well as maintained. For any chemical reaction, chemists try to find out three aspects, that are feasibility of the reaction, extent of the reaction and rate of the reaction. What is feasibility of the reaction? The feasibility of different reaction is checked with the help of thermodynamics. The reactions with the free energy change delta G less than 0, that is negative, are feasible or possible. And the extent to which a chemical reaction will proceed can be determined from chemical equilibrium. And the rate of reaction can be determined by kinetics. And what is a rate of a reaction? The rate of the reaction is the speed with which the reaction takes place. Certain reactions which take place fastly, certain reactions which take place slowly, some others which take place moderately. There are different types of reactions. Based on this, the reactions are classified as slow reaction, fast reaction and moderate reaction. For example, ionic reactions take place in solution are immediately completed. That is example for fast reaction. Precipitation reaction, neutralization reaction, these are fast reactions. Arresting of ion, conversion of graphite to diamond, these are slow reaction. And fermentation of grapes leading to alcohol is also very slow reaction. And hydrolysis of cane sugar, decomposition of hydrogen peroxide, these are moderate reactions. These reactions which take place moderately. And what is chemical kinetics? It is branch of chemistry which deals with the study of reaction rates. And the word kinetics is derived from Greek word kinesis, meaning movement. In definition, chemical kinetics is physical chemistry that deals with the study of rate of reactions, the factors that affect those rates, and the mechanism by which they proceed. What is rate of chemical reaction? As the reaction progresses, the reactant concentration gradually decreases and the product concentration gradually increases. And rate of reaction is the change in concentration of reactants of a reactant or product in unit time. Rate of chemical reaction, it is defined as the rate at which rate of decrease of concentration of reactant or rate of increase of concentration of product, and usually expressed in unit, mole, liter inverse, second inverse. Let us take an example. A gives B. And what is the rate of this reaction? Rate of disappearance of A, which is equal to decrease in concentration of reactant per unit time or time taken for change, and which can be expressed as minus dA by dt, where dA is the change in concentration, dt is the time. Why we write negative here? Because decrease in concentration of the reactant per unit time is the rate of reaction here, and rate of formation of B, which is equal increase in concentration of product, that is dB divided by time taken for the change, dt. And the graphical representation of rate of reaction shown in this figure. Here decrease in concentration of reactant and increase in concentration of product is shown. Chemical reactions are classified on the basis of reaction rate, that is instantaneous rate and average rate. Average rate is the total change in concentration of reactants or product by elapsed time, or it is defined as the rate of change of concentration of reactant or a product during the time interval chosen. And instantaneous rate, it is the change in concentration of reactant or product at particular instant or time. Average rate is denoted by delta H by delta T, and instantaneous rate is denoted by dx by dt. The average rate of a reaction can be determined graphically. A graph is plotted between different values of molar concentration of reactant on y-axis and the corresponding values of time on x-axis. We have studied that rate of concentration of reactants decreases with the time. Let X1 be the molar concentration of A at time T1 and X2 be the molar concentration of A at time T2. Then change in molar concentration equals H2 minus H1. Change in molar concentration equals H2 minus H1, and change in time, that is T2 minus T1. T2 minus T1. Then rate of reaction equals rate of change of molar concentration of reactant divided by time, unit time, that is R equal delta X by T minus delta X by T. Why we put minus here? Because the rate of reaction of reactant is the decrease in concentration, molar concentration of reactant per unit time. That is H2 minus H1 divided by T2 minus T1. That is the average rate. The average reaction rate does not give the true rate of the reaction. That is one of the limitations of average rate. Actually, the change in molar concentration of particular species for two same gaps of time intervals is not same. This is because of the reason that the change in molar concentration is related to the actual molar concentration. Since actual molar concentration changes with the time, therefore change in molar concentration also changes, and so it is rate reaction. What is instantaneous reaction? The chemical reaction which are completed the moment the reactants are mixed are called instantaneous reactions. Generally, the reaction in ionic compounds taking place in aqueous solution belongs to this type. For example, on mixing aqueous solution of AgNO3 and NaCl, a white precipitate of AgCl silver chloride is formed in no time. In fact, in ionic reactions, the reactants immediately change into ions in solution without involving any energy. These ions simply regroup and form the product. These reactions are extremely fast and therefore not possible to study their rates. And now you have get an idea what is instantaneous reaction, which take place very fastly. But spontaneous reactions may not be fast reactions. For example, evaporation of water is spontaneous in nature, but it is slow process. In order to have true picture of the reaction rate, one should know the rate of reaction at any particular instant during the course of reaction. Such rate is known as instantaneous rate, or we can say the average reaction rate at the smallest interval of time, that is dt, when delta t approaches to 0. We can also measure the instantaneous rate using graph. In order to determine the instantaneous rate with respect to reactant R in the reaction, R gives P. This is the reaction. A graph is plotted between different molar concentration of A, corresponding and the corresponding values of time t. In order to know the rate of reaction at any instant of time, a tangent is drawn to the curve. A tangent is drawn to the curve at the point y, corresponding to the time as shown in this picture. And the slope of tangent gives the instantaneous rate at that instant of the time. Thus, instantaneous rate equal OQ divided by OP, which is equals minus dx divided by dt. We have studied now instantaneous rate of a reaction can be found from slope of tangent to the curve obtained by plotting time versus concentration of the reactant or product at the point which corresponds to that instant of time. To get true picture of the rate of the reaction, we should have to know at what instant the reaction is take place. And next we are going to discuss about measurement of average and instantaneous rates graphically with respect to the products. In a chemical reaction, we normally start with the reactants, since no products are initially present. Therefore, both average and instantaneous rate are determined with respect to reactants only. We can also study the curves for both these reactions rate. that is with respect to products also. From the graph we can calculate both the instantaneous reaction rate and average rate. Instantaneous average rate is equal to H2 minus H1 by T2 minus T1, and instantaneous is given by slope. And from the nature of curves plotted with respect to reactants or products, it is quite clear that these are not linear. This means that the reaction rate is not constant. It changes with time. Let's do a problem. Nitrogen dioxide NO2 reacts with the fluorine F2 to form nitrile fluoride NO2F. According to the reaction, 2NO2 gas plus F2 gas gives 2NO2F. Write the instantaneous rate of the reaction in forms of, first is rate of formation of NO2F. What is the rate of formation of NO2F? Rate of formation of NO2F. Rate equals D NO2F divided by dt. Then what is the second question? Rate of disappearance of NO2, which is equal minus d NO2 by dt. Then third question, rate of disappearance of F2, that is minus d of, because it is in reactant site, F2 divided by dt. Next reaction, A plus BB gives CC plus DB. In this reaction, the stoichiometric coefficients are not same. So for expressing the rate of such reaction, the rate of change of concentration of each species is divided by its stoichiometric coefficient. Here A, B, C, D all are stoichiometric coefficients. In order to write the rate of reaction, we have to divide the stoichiometric coefficient with the rate of change of concentration of each species. So rate of reaction equal minus 1 by A d of molar concentration of A by dt, which is equals minus 1 by B dB by dt equals 1 by C d C by dt equals 1 by d of molar concentration of D by dt.